The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
So this is Chem 1025 Exam 2, question number 4. So question number 4 says, calculate the empirical formula for methyl butyrate based on its smell, or component of appletase and smell, based on its elemental mass percent composition of carbon, which is 58.80%, hydrogen, which is 9.87%, and oxygen, which is 31.33%. Anytime you're doing a percent composition question where it gives you the compositions for each of the three, what I do is notice that 58.8 plus 9.87 plus 31.33 is equivalent to 100. So anytime I do a question like this, I just assume that everything equals 100 grams. That way I'm not dealing in percent, but I'm actually dealing in grams. So we have 58.80 grams of carbon. We have 9.87 grams of hydrogen, and we have 31.33 grams of oxygen. Now, once we know how many grams of each we have, in order to determine the formula, we have to know the atomic mass for each of the elements. So we know from before that the atomic mass of carbon, so AMU of carbon equals approximately 12.00 grams per mole. Hydrogen is about 1.01 grams per mole, and oxygen is about 16.00 grams per mole. So what happens is, if we divide each of these grams that we have by the atomic mass, we're going to know how many total carbons, how many total hydrogens, and how many total oxygens are in this. So the first thing we're going to do is we're going to divide 58.80 by 12 grams per mole. And that's going to give us 4.9. So carbon, we have 4.9, or we have approximately 5 carbons. Hydrogen, 9.87 divided by 1.01, 9.77. So hydrogens, we have 9.77, which is approximately 10 hydrogens. And finally, if we do 31.33 divided by 16, we get 1.96 for oxygen, which is approximately 2 oxygen atoms. So, now if we see this, if we ever had something say 5.5 or 10.5 or 1.5, we would have to double everything, because a 0.5 we don't know, is it 1 carbon or we don't know if it was 2 carbons. So what we'd do is we'd have 1.5, double it, then we'd have 3 carbons. But for this question in particular, our formula ends up being C5H10O2. And if we go and look at our choices for exam 2, question number 4, answer choice number 5 says C5H10O2, and that's the correct answer choice. So question number 4 is answer choice number 5.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.